So moving to the first question from level 1. When a mirror is rotated through an angle theta, the reflected ray from it turns through an angle theta, angle of, you are asking. Children, let us recall back the concepts which I have discussed earlier. So what was that? So whenever we were given a mirror and the mirror is rotated by an angle theta, we observe that the normal also turns by an angle theta, whereas the incident ray being fixed, the reflected ray deviates by an angle or rotates by an angle 2 theta. Let me write the same here. So whenever a mirror is rotated by an angle theta, we observe that the normal also turns by an angle theta, whereas the incident ray being fixed at the same position, that means no difference in the angle. So it is deviated by theta, no difference, no deviation, so angle is 0. The reflected ray is found to be deviated by an angle 2 theta. So this was all our observation while what we have discussed earlier. So now the question was, when a mirror is rotated through an angle theta. So given that the mirror is rotated by an angle theta, the reflected ray from it turns through an angle of how much? How much is that angle, children? It was found that 2 theta. Hence the correct option is option 3, that is 2 theta. Got it? So shall we move to the next question, that is question number 2. If a mirror is rotated by 10 degrees, so what it was given is the mirror is rotated by 10 degrees, the reflected ray is rotated by what angle? Just now we have discussed that whenever a mirror is rotated by an angle theta, we know that the reflected ray turns by an angle 2 theta, but here the value of theta is given as 10 degrees, then the value of 2 theta must be equals to 2 into 10, that is 20 degrees. Hence the correct option is option 2, that is 20 degrees. Clear? Okay. So moving ahead with the next question, that is question number 3. So what is given? On rotating a mirror through an angle of 20 degrees. Now the mirror was rotated by an angle of 20 degrees. The reflected ray is found to get deviated or turned back or rotated, meaning same. Okay. Through an angle of, let us write down. So given that mirror is rotated by an angle, T must be rotated by an angle. Deviated or rotation, both means the same, keeping the incident ray fixed. Then reflected ray turns by 2 times of 20 degrees and it is found to be 40 degrees. Hence the correct option is option 3, that is 40 degrees. Got it, children? Well, so now let us move to the next question, that is question number 4. Here we go. A ray of light is reflected from a plane mirror. So a ray of light is reflected from a plane mirror so that the angle between the incident and the reflected ray is 60 degrees. Let us visualize the same. So what is given? A mirror is given. From this mirror, it was given that a ray of light is reflected from a plane mirror so that the angle between the incident and reflected ray is 60 degrees. So if this happens to be incident ray, then this will be a reflected ray. And the total angle I plus R is given as 60 degrees. If the mirror is rotated to increase the angle of incidence by 3 degrees. Okay. So now what happens means, so earlier the angle was, if I plus R equals to 60 degrees and since I is equals to R, this implies that since from law of reflection we know that I equals to R. So wherever you find R, you can replace it with I. So I plus R is replaced with I equals to 60 degrees. This implies 2I equals to 30 degrees, or the value of I is found to be, 60 degrees, or the value of I is found to be 30 degrees. So clearly the angle of incidence is equals to 30 degrees given. The angle of incidence is given as 30 degrees. If the angle of incidence is 30 degrees, the angle of reflection must also be 30 degrees. That's it. Ray of light reflected from a plane mirror so that the angle of between the incident and reflected is 60. That means angle of incidence is 30 and angle of reflection is also 30. Now if the mirror is rotated to increase the angle of incidence, earlier the mirror was like this, now the mirror was increased such that, okay, rotated such that the angle of incidence is being increased by 3 degrees. Whenever the angle of incidence is increased by 3 degrees, what about the reflected ray? Reflected ray also increases by 3 degrees. So, new position of I dash is given as 30 degrees plus 3 degrees, that is 33 degrees. Then the new position of reflected ray is also 30 plus 3 degrees. Now the incident ray they have changed. Okay, difference they are telling is also found to be 33 degrees. Theta. That means theta, earlier it was given as I is equals to 30 degrees and theta is equals to 3 degrees. Okay. So, it's clear? Or else I will tell you something. I dash can be written as I plus theta. R dash can be written as I plus theta. This is what we have discussed in the concept. Hence, so this is given as 30 plus 3 degrees, that is equals to 33 degrees. This also 30 plus 3 degrees, this is found to be 33 degrees. Now you are asked to find out the new angle between the incident ray and reflected ray. So what is the new angle between the incident ray and reflected ray? The total angle between the incident ray and reflected ray is found to be 33 degrees plus 33 degrees and it is equals to 66 degrees. So this is also deviated by theta, this is also deviated by theta. Now the new position between the incident ray and the new reflected ray overall is found to be, okay, how much is that children? 2i plus 2 theta, and that is found to be 2 times of 30 plus 2 times of 3, that is equals to 60 plus 6, found to be 66 degrees. Okay, is it clear? Okay, then let us move to the next one, that is question number 5. A ray of light reflected from a mirror rotated through an angle 20 degrees. Okay, the reflected light is rotated by an angle 20 degrees. When the mirror was rotated, the deviation produced in the reflected ray is given as, that is 2 theta is given as 20 degrees. What is the angle of rotation of mirror? So, given condition is that reflected ray is rotated by 2 theta. So, this is nothing but 2 in, and this is given as 20 degrees. 2 theta is given as 20 degrees. Then the rotation of how much the value mirror is being rotated. So, mirror can be rotated by theta only. So, theta means half of that, that is 20 upon 2. So, that is equals to 10 degrees. 2 theta is 20 degrees, then theta must be equals to half of 20, that is 10 degrees. Hence, the correct option is option 1, that is 10 degrees. So, in the reverse way they have given us. Earlier they used to give us rotation of mirror angle. You are asked to find out reflected ray angle. Now the reflected ray angle was given and mirror rotation is being asked. So let us look into the next question, children, that is 6th question. If a mirror is rotated by 10 degrees, mirror rotation now given, no doubt. If the mirror is rotated by 10 degrees, the normal is rotated by, children, we know that whenever a mirror is rotated by theta, normal also rotates by theta, whereas the reflected ray rotates by 2 theta. So, the line normal rotates by theta only. So, theta only, this given as 10 degrees, then this also will be equals to 10 degrees. Hence, the correct option is option 1. Over. So, moving ahead with the next question, that is question number 7. A ray of light from a lamp, fall normally on a vertical plane. So, first of all, let us consider that vertical plane. So, here we go. Consider a vertical plane mirror. This is the given vertical plane mirror. Okay. So, vertical plane mirror is being given. A ray of light from a lamp falls normally on a vertical plane mirror. So, first of all, let us visualize a lamp, and from this lamp it was given that a ray of light is passing by. A ray of light from a lamp falls normally on a vertical plane mirror at a distance of 1 meter. So, what is the distance here given? 1 meter distance is given, and its image is formed on a scale placed just above the lamp. So, light is incident. So, direction of incident ray is something like this. Okay. That means the light ray is falling normally. Whenever the light ray falls normally, the angle of incidence is equals to 0 degrees. We know, because see, if this is the mirror and this is the normal, whenever a light ray is incident something like 45 degrees, reflected ray also passes by 45 degrees. 30 degrees means the reflected ray also passes by 30 degrees. And similarly, if the light ray is incident lesser below and directly if it is falling towards the normal, then again it reflects back on the same direction. That is, angle gradually decreases, and whenever the light ray passes through the normal, the angle of incidence will be 0 degrees. Hence, the angle of reflection is also 0 degrees. So, in this case, very clearly, the angle of incidence as well as the angle of reflection is 0 degrees. It passes directly through the normal and again comes back through the normal only. So, no deviation is produced. Until here it is clear. So, a ray of light from a lamp falls normally on a vertical plane mirror at a distance of 1 meter, and its image is formed on a scale placed just above the lamp. So, image is being observed. When the mirror is rotated through an angle theta. So, now what is the next step means this mirror is being rotated by some length. So, let us suppose that this mirror is now rotated to a new position. Let this mirror be rotated through a new position, something like this. Yes. And what is the angle of rotation they have given, children? The angle of rotation between these two, they have given it as theta. So, when it is rotated through some angle theta, then the normal also shifts by some distance. The normal also shifts by some distance. So, this pink color indicates the normal drawn to this yellow one, whereas the green normal indicates the normal drawn to that green one. Okay. So, pink, I will change the color to yellow best. Yes. Okay. This was the initial position of the normal and this indicates the new position of the normal. So, as the mirror is shifted by an angle theta, of course, normal also shifts by an angle theta. So, whenever the normal shifts by an angle theta, the initial incident ray remaining the same, the reflected ray now passes in this particular direction. The reflected ray passes in this particular direction. And it was given that Yes, this is better. It was given that as the normal, initial position of the normal was this yellow and new position of the normal was theta. Okay. So, whenever normal shifts by an angle theta, we know that the reflected ray shifts by an angle 2 theta. Normal shifts by an angle theta means the reflected ray shifts by an angle 2 theta. Mirror rotates by an angle theta. Normal shifts by an angle theta, whereas reflected ray shifts by an angle 2 theta. So, where was the initial reflected ray? Here was your initial reflected ray, this incident ray as well as normal, same direction. This was your initial incident ray and hence the reflected ray. So, initial reflected ray was this and final reflected ray was the latter one. So, this reflected ray shifted by 2 theta. Mirror shifted by, turned by theta means reflected ray shifts by 2 theta. So, no doubt the angle between the two reflected rays, the first reflected ray and second reflected ray is found to be 2 theta. Is that point clear, children? So, this was your initial reflected ray and here was your final reflected ray, and the angle between the two reflected rays, no doubt it is 2 times of the theta. This is theta, this is 2 times of theta. And it was given that the spot of light on the scale is displaced through 10 centimeters. Earlier the spot of light was here, now the spot of light is displaced by 10 centimeters. This distance is given as 10 centimeters. Up to that it is clear, children. So, this is the given data. You are asked to find the value of theta. If the question is clear, I will extend the part. So, what was your observation is that you can observe a right angle triangle in the figure. So, focusing on that right angle triangle as shown in the figure. So, let us look at the right angle triangle, something like this. So, here the angle was given as 2 theta. This distance was given as 1 meter and this distance was given as 10 centimeters. In a right angle triangle, we can see 2 sides and 1 angle is known. So, opposite side as well as adjacent. When opposite side and adjacent side are known, you have to take which trigonometric function, children? Of course, it is tan function. From the right angle triangle, consider tan theta. So, tan 2 theta equals to opposite by adjacent. Opposite side is 10 centimeters upon 1 meter. Converting it into same units, it can be written as 10 centimeters, 1 meter carries 100 centimeters. Okay. So, now these two will get cancelled. 0, 0 gets cancelled. Same units, should not cancel but same units. Okay. Then what are you left with? Tan 2 theta is equals to 1 by 10 or tan 2 theta is equals to 0.1. Children, as it is the quotient when the distances are being cancelled, then the units will be radians. You will get it in radians, not in degrees. Children, one thing you need to know, this distance is very small, that is hardly 10 centimeters. Okay, 10 centimeters means we are getting it as radians, this means 0.1 radians, and no doubt the 0.1 radians is a very small value. Okay, or else I'll just look into that. If you want to convert radians into degrees, one thing you need to remember that 180 degrees is equals to pi radians. If 180 degrees is equals to pi radians, then 1 radian must be equals to 180 by pi degrees. If 1 radian is equals to 180 degrees by pi radians, then 1 radian into 5 must be equals to 5 times of 180 into 10 is equals to 10 times of 180 by pi. Similarly, if this is some x radians, means this is also x radians. But here how many radians they were given? They have just given it as some 0.1 radians. So this should be multiplied with 0.1 radians to convert it into degrees. So clearly tan 2 theta can be written as 0.1 into 1 radian is equals to 180 degrees by pi, 180 by pi degrees. Hence, tan 2 theta is equals to 0.1 into 180 is found to be 18 upon the value of pi is found to be 22 by 7. Hence, tan 2 theta is equals to 18 into 7 upon 22. Multiplying we get 8 sevens 56, 126 upon 22. Simplifying further, this goes 63 times and here goes 11 times, and finally this value is found to be 11 5s 55, remainder 8, so 80 means 70, okay, something like this, 5.7, 30, 11 2s, okay. And again 5.727 or approximately you are getting something like this, 5.727 or approximately, let me take it as 5.8, approximately let me take it as 5.8. Tan 2 theta we hardly get it as 5.8 degrees, and 5.8 degrees is a very small value. For smaller values of angle, remember children, the trigonometric function like sin theta is approximately taken as theta, whereas tan theta is approximately taken as theta only for smaller degrees which is less than or equals to 5. Okay, so very for small angle. So for this, as the angle is very small, I can approximately consider tan 2 theta as 2 theta. So 2 theta is found to be 5.8 degrees, or theta is equals to 5.8 upon 2, and that is equals to 2.9 degrees. So how much is the angle? How much is the mirror is being rotated? The mirror is being rotated by an angle of 2.9 degrees, and hence the first option is true. Children, concept is easy. Only thing is that you should be clear with the trigonometric functions and the conversions of the degrees and radians. That's it. Then you'll get the answer. Okay. Well, so moving ahead with the next question, children, that is question number 8, multi-answer type questions, multiple type questions. Okay. So more than one option is true. So let us look into the question carefully and then let us answer. The first question it was given is, of a plane mirror is rotated by an angle theta for a fixed incident ray. Of course, incident ray is fixed and the mirror is rotated by an angle theta. Then what is our observation? We often observe that the normal rotates by an angle theta. The normal rotates by an angle theta. So of course, the first option must be true. The reflected ray rotates by an angle theta. Is it theta? 2 theta. The reflected ray must turn by 2 theta, not theta. So this is a wrong statement. Here it was given that normal ray rotates by an angle 2 theta. No, because we just now we have discussed that the normal ray, whenever mirror rotates by an angle theta, normal also rotates by an angle theta. So if this is true, this must be false. And the reflected ray must rotate by an angle 2 theta. That's true. Clear? So we observe two statements are true. That is the first one as well as fourth one. Both are true. Hence we have two correct options.